Okay, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera to everyone. Today I would like to present my paper title of Modeling and Performance Evaluation of Self-Tuning Fuzzy PID Controller for Hydro Distillation Process. I am Nurul Nada Muhammad and the rest is my colleague. We are from UiTM Johor Campus Pasir Gudang, Department of Electrical Engineering. This is the outlines of the presentation today, which includes previous research on essential oil, previous research on temperature control effort, previous research on control strategy, objective, background study, methodology, result, conclusion, and acknowledgement. Okay, this is the introduction on previous research on essential oil. Presently, essential oils are greatly gained interest in research area because of the diverse applications that brings benefit to human and industry. It is widely used in pharmaceuticals, perfumery, food industry, cosmetics, aromatherapy, and also agriculture. The essential oil can be obtained by extraction, either using conventional method or advanced method. The formerly extraction technique introduced was distillation. Distillation is an ancient and easy method in order to extract essential oil. Therefore, distillation is categorized as a conventional extraction that can be accomplished by using hydro or steam distillation. Okay, this is the previous research on temperature control effort. Okay, in extracting essential oils, okay, there are parameters that have to be concerned which may affect the yield and also the quality of the pure essential oil. Those parameters are pressure, distillation time, composition of chemical substance, and the size of the raw material. However, the temperature is the most critical parameter that will affect the quality of oils. The temperature has difficulty in handling and controlling since they experience a non-linear behavior, and moreover, mostly the extraction process was operated under little or no supervision that monitor or control the temperature during the extraction. Therefore, in this study, monitoring temperature control is important in extraction and it is chosen as a process variable to the proposed research. Okay, this is the previous research on control strategy. In this study, we are focusing on PID controller and fuzzy logic controller. PID controller is the most interest and has sustained their popularity because of its simplicity and understandable control action. But unfortunately, PID control has some drawbacks which unable to control the process which large constraints. Okay, therefore, advanced controller has been applied to enhance the conventional controller, like we have a fuzzy logic controller, self-tuning fuzzy PID, model predictive control, and others advanced control technique. So, fuzzy logic controller is an intelligent control strategy that apply linguistic rules that highlight some advantages where it is not require a mathematical model structure and can handle the non-linearity process. Nevertheless, the fuzzy logic controller has some drawbacks where the tuning process is tuned manually that based on the try and error method and eventually it is time consuming. Therefore, self-tuning fuzzy PID can further simplify this problem. Self-tuning fuzzy PID is an adaptive control where the parameter of PID, which is Kp, Ki, and Kd, are tuned automatically. The altering of the PID parameter is the principle of fuzzy control that acts as a supervisor, which is always attempting to recognize the PID to be tuned properly. So in this study, the objective is to model the water temperature of a hydrodistillation process by using first order plus that time FOPDT model, and to demonstrate the performance comparison of self-tuning fuzzy PI and also self-tuning fuzzy PID controller. Okay, the background of this study was FOPDT model will be constructed to present the compact hydrodissociation process, and then the PID parameter is acquired to design the self-tuning fuzzy PI and self-tuning fuzzy PID controller. Moreover, the comparison performance of STFPI and STFPID with 25 and 49 fuzzy rules will be analyzed. So this is the methodology that involved in this study. So first step is by doing step test by an open loop experiment, and then construct FOPDT model, and then we implement the PID controller and fuzzy logic, and then lastly evaluate the performance, okay, based on transient response. So okay, as you can see, the figure 2A is the output response of an open loop test, and B is the step input signal. Okay, as you can see in this study, the open loop experiment has been done with 3-volt step input signal. As we can see, there was a spike at 200 and 2200 seconds. Okay, this incident happened because of the high pressure that forced the pressure to be released. From this open loop experiment, FOPDT model is being developed by using process reaction curve. So the process reaction curve has used to obtain the FOPDT model by using 2-point method, which is at 28% and also 63%. From the process reaction curve, the time constant, time delay, and gain has been get, and the FOPDT model have been obtained. So this one is the methodology for PID controller. Okay, as you know, the PID controller consists of 3 terms, okay, which is proportional gain, integral time, and also derivative. Okay, and these terms have their own capability and majorly depends on those parameters to achieve the required response that will affect the performance of the control process. In this study, the parallel form of PID controller has been used that listed in equation 6, and the Ziegler-Nichols is selected to perform as the FPID and also as the FPI later on. Okay, this one is the self-tuning fuzzy PID controller. In designing the STFPID, there are 2 inputs involved, which are error and also derivative of error, whereas the output are KP, KI, and also KD. This controller is attempting to tune each parameter to the parameter of the PID. With combination of this controller, fuzzy control will act as a supervisor, means that it always attempting to recognize the PID in order to tune the parameter properly. The gain will adjust the respect to a set of fuzzy rules, okay, to achieve the best performance, since the fuzzy rules presented the relationship between error and also the derivative error in the adjustment process of PID parameter. As you can see here, figure 5 and figure 6, okay, depict the 7 times 7 and 5 times 5 membership function of input fuzzy set for the error. respectively. Here the range is set to -100 to 100 as it presented the full scale of the water temperature. Okay, so the notation of the membership function, as you can see here, MB, NM, NS, ZE, PS, PM, PB is referred to negative big, negative medium, negative small, zero, positive small, positive medium, positive big. Okay, and here same goes for the derivative error for 7 times 7 and 5 times 5. Okay, the range is in -15 to 15 because it used to eliminate the unwanted noise and fluctuation that generally occur in the temperature process control. Okay, this is for the output membership function. Okay, for 7 times 7 and 5 times 5. Okay, the range was normalized and then we'll multiply with a constant gain for the real control output. Okay, next is the table for fuzzy rules. Okay, that map based on the mapping of input output of the membership function respectively. Accordingly, there are 49 rules for 7 times 7 and 25 rules for 5 membership function. They were developed that based on the input of the fuzzy set, and the PID gain was tuned according to these fuzzy rules. Okay, this part is for result. So result we have uh, three test, which is step test, set point change test, and also load disturbance test. Okay, so look at for step test result. As you can see here, the fuzzy PID membership function successfully performed for all transient response criteria. Okay, and for the rust time, it showed that the self-tuning fuzzy for both PI and PID and PI are not much differ. As you can see, is the plus around +2, +4. Okay, other criteria which is in terms of percentage overshoot. Fuzzy PI membership function 5 give large overshoot, meanwhile fuzzy PID membership function 7 produce very small among the other controller. For settling time, the result indicate that fuzzy PID membership function have faster response than other controller. So for the overall result, it shows that membership function 7 perform better than membership function 5 for both self-tuning fuzzy PID. This one is the result for set points change test. So as you can see that the various operating temperature was set at 75, 80, 80 and also 85 degree. Okay, so referring to the table, referring to the result, the fuzzy PID membership function able to fulfill all the transient response criteria, which give the faster response in rise time, settling time for all the operating temperature compared to other STF PID and also STF PI. Okay, moreover, fuzzy PID membership function gives more percentage overshoot compared to other controller. For fuzzy PI controller, membership function 7 give better performance than membership function 5 in terms of rust time, settling time, and also percentage of overshoot. However, all the self-tuning fuzzy PID had some oscillation in order to reach the set point. Okay, for the last result is the load disturbance test. The load disturbance test here has been done to test the potentiality of the each controller to return according to the set point, and the time recovering indicate the set indicate the time recovering indicate the which controller managed to reach the set point after experiencing the load disturbance. Okay, as you can see here, the load disturbance have been performed right after the system reached the set point, and also steady state condition that was at 85 degrees Celsius, which around 2000 seconds. From the result obtained, it showed that fuzzy PID membership function able to reach the set point back after undergone the load disturbance. Moreover, fuzzy PI membership function took largest time in order to reach the set point. Okay, for the conclusion, the fuzzy PID controller based on FOPDT model for compact hydrogenation was presented, and this study had analyzed the performance of self-tuning fuzzy PID controller for 7 and 5 membership function. The performance has been evaluated that based on transient response, which is rust time, settling time, and percentage of overshoot. From the overall result obtained, it can be concluded that a self-tuning fuzzy PID with 7 membership function gave understanding performance compared to STF PID with 5 membership function, and same goes for self-tuning fuzzy PI with 7 membership function gave outstanding performance compared to self-tuning fuzzy PI with 5 membership function. This research is funded by UiTM Campus Johor under Best Study Grant, and this is the references, and this all for me, and thank you for listening.